Hey, how's it going? In this video, we're going to talk about relations in the context of TypeORM. So on the screen here, we have an example ERD relationship diagram, and this is what we're going to build in this tutorial. On the right, we have, if you're not familiar with the notation of this diagram, you can take a look. If you want to follow along, I suggest you maybe pause the video at this point and draw this diagram on a piece of paper, so that you can kind of understand what I'm doing in the code as I'm typing it out. I also wrote this set of requirements to kind of, for the people not as familiar with what this diagram means, here's basically what we're trying to build, right? We're going to have an employee table, which is self-referencing. So an employee, for example, could be a manager, right? And a manager can have direct reports. But all those different types of people are represented in our database as an employee. So we need to be able to have a self-referencing column here where an employee can have a manager, hence manager ID. And then an employee also has a one-to-one relationship with contact info, right? There shouldn't be anyone else with the same contact info as them. So there's one and only one contact info per employee. And then next, an employee also has one-to-many tasks, right? Maybe they have projects or stuff to do. On the top here, you can see that there is a many-to-many relationship between employees and meetings, right? So an employee can belong to multiple meetings, and meetings can have, any number of employees as attendees. And that relationship is represented via this kind of intermediary relationship table. So I do kind of expect that you have a little bit of fundamentals when it comes to SQL and relational databases. So I'm not going to go into too much detail describing, what are the differences between these relationships. Just know that this is what we're going to try and emulate. This is our requirements, and I'm going to show you how to do that in TypeORM. So with those requirements out of the way, let's jump right into the code. And what I have here is a basic Nest.js application. Now, you don't necessarily need to use Nest.js or TypeORM with Nest.js, but people that do use Nest.js, there's a high tendency that they'll probably use TypeORM, so I figured it kind of makes sense to do it in this context. Now, I'm not going to go over how to set up everything from scratch in terms of database connections and stuff, so I already kind of pre-configured this to have a connection to a SQLite database. And I have another video specifically on the fundamentals here of how exactly you would set up these connections, these configurations. This is probably a good video as a follow-up to that first video. So if you're completely new to TypeORM and Nest.js, you might want to check out that video first. So real quick, let's walk through the code that we have. So like I said, we simply just have some configuration here to spin up basically a fake database, right, using SQLite. And it's just locally saved in a file in my desktop. You'll notice that our basic application here has this app service. This is where we're going to put our database logic, our querying, and then this is referenced in app controller, which just allows us to kind of trigger this logic to run, right? So that's kind of our bones. That's what we're going to get started with. All right, so first we need to create our database tables, right? And if you've seen my last video on TypeORM, you know that usually the way to do that is by creating entities which represent your database tables. All right, so why don't we start with the employee entity. So I'm going to create a new file called employee.entity.ts. And this is just going to be a class called employee. And remember that this needs to be an entity. We're going to add a primary generate column. This just means that we have an auto incrementing int from the database perspective. So each time you insert an employee, it's automatically going to use a number that increments by 1 each time. Next, we'll just add a basic name column, which is just a string or a varchar from the database perspective. And that's it for now. We'll start with that. All right, from here, let's talk about our next table, which is the contact info table, which I'm going to create a new file for, contactinfo.entity.ts, and I'm just going to copy the same exact structure here, and of course we're just going to change the things that we need to change. So make this contact info. It's gonna have its own ID as well that is also primary generated. But let's change this name column to what do we have in our diagram? I think we had phone. Let's make this one nullable. And let's add another string column, which is email, which is not nullable, right? So you have to have an email for every employee. Now this is where we start to set up our first relationship, which is this one-to-one relationship between contact info and employee, right? So the way you do that is you add a new property here which represents that relationship. In this case, we're gonna say employee, right? Type employee, i.e. our employee entity that we just created, and then we're gonna tell TypeORM what this is exactly, which is a one-to-one relationship. And the thing you have to pass in here is a function which returns the type, which is basically the same as this, right? So we just put employee in here, and then the next thing you need to add is a join column. Now the join column basically tells us where is the relationship ID created, right? If we go back to our diagram, you'll see that our contact info has an employee ID, right? So that's there because we have join column over here. If we were to put the join column in the employee table, what we will have is an employee table with a contact info ID. And this is also mentioned in the documentation for one-to-one. If my explanation didn't make much sense, but you'll see it'll say that we also added the join column, which is required and must be set on one side of the relation. So whoever side that is on will have the relation ID and the foreign key for that relationship. So what this means basically with the join column is TypeORM is going to add a employee ID column to our table automatically without us having to specify it as a column like these guys, right? You can also add it in like this if you wanted to, which is going to give you sort of direct access, but think of it as it's implicitly already defined for you. You don't have to do it manually, but there is benefits to sometimes putting it in here manually anyways. For example, if maybe you want to query a contact info and be able to tell what the employee ID is without having to make that join with the employee to then get the ID. So it's pretty useful to have it in your model like this so that you can reference it if you wanted to. So what we have here effectively is a unidirectional relationship, meaning that the relationship that we wanted out of this diagram is already established. However, from TypeORM's perspective, there's no easy way to query what the contact info is from the users table. So what we can instead do here to kind of improve upon that is we can make this a bidirectional relationship. And the way to do that is we're going to add employee here, and we're going to specify basically on the other side of the entity, the employee entity, what is the property that relates to, that maps to this. So let me type this out, and then I think it'll make more sense in a second here. So on the employee entity, it's going to be contact info. Now notice that there's a red squiggly there because we don't have that yet. So to fix that, we're going to add contact info here, which has a type of contact info. Now similarly, we're going to add that one-to-one decorator here, and we also need that function which tells us what's the type. A little bit redundant, but that's how you're supposed to do it. And then similarly, we provide another function to tell us, all right, in that entity, what property does it map to, which we already have. So it's just contact info.employee. So putting this side by side, you'll see that what this is saying is that we have a contact info which has a type of this guy on the right, and we kind of know that it maps to this employee field over here, right? And notice that I don't have to put the join column on this side because that's already on this side. It only needs to be on the side which you want the relationship ID to be in. Right, so if we go back to our requirements here, we made the employee table And we also created the info table, and there is a one-to-one relationship with employee. I know I'm kind of jumping around here, but we'll get back to these other guys in a little bit. And we also have the bidirectional relationship between, coming from the employee side. Now you might be wondering, what scenarios would you do unidirectional versus bidirectional? Well, if you don't know, I would suggest you just do the bidirectional, which is going to be more flexible for you, as you'll see later in this video when we start doing querying. But basically, for example, if you're on the employee table and you want to be able to query employees with their contact info, you probably want to have that here. If you don't need that, then you can do a unidirectional relationship. Now there's one more requirement that we didn't get to, which is we said that we want to be able to make sure that contact info is deleted if the employee itself is deleted. We don't want to have contact info that's kind of just floating in space, right? So the way you can do that is on the contact info entity, you can pass a third argument to this on the one-to-one decorator, and you can add extra configuration here. So for example, you can add on delete, we'll do cascade, right? And what does this mean? It's saying that on delete, if this employee got deleted, cascade that delete to this record, this contact info record. So if the employee got deleted, their contact info gets deleted as well. If you know your SQL well, I bet that already makes a lot of sense to you. So we'll just move forward from there. All right, next let's talk about task, which in our diagram is this guy on the bottom here, which just has a name, and you can see there's this relationship with the employee ID, right? So we're going to create another file, task.entity.ts. To save you some time, I just typed this out. So kind of same thing, right? It's got its own ID, primary generated. It's got a name column. Now let's add the relationship between this task table with the employee table. So we said that an employee effectively has one too many tasks. It might be simpler for us to start adding it on the employee entity here. So we're going to add tasks, which has a type of task, but as an array. And then we're going to say that we have a one too many relationship here. And similarly, we specify what's the type and what does it map to on the other table or entity. In this case, we're going to do task dot employee. All right, again, it's red because it doesn't exist yet on this side, the task side. So we're going to add a employee property here of type employee, and we're going to say this is a many to one, right? The inverse of one to many, right? Again, provide your type. I really wish it was able to determine this automatically based on the TypeScript type here, but it doesn't. So there you have it. So let's do employee.tasks, the thing we just added earlier. So you're probably starting to see the patterns here, right? And then on the third thing here, we said that if an employee gets deleted, we want to set the employee, the assigned person to this task, to be null, right? So we're going to do on delete set null, which makes sense if you think about it, right? If you're in a company and perhaps you have a set of tasks, if one of those employees left, you don't want to just delete their tasks, right? You'll probably want to unassign them and then reassign them later to someone else who is still in the company. So that's why we're doing set null. All right, so that was pretty straightforward. Back in our requirements here, we made a task table, we made a many-to-one relationship with employee, and we said employee ID becomes null if employee is deleted. And then on the employee side, we said that we have a one-to-many relationship with tasks, as you can see here. All right, so pretty simple, right? So now that we kind of have a pattern for how to do one-to-many, many-to-one, this is probably a good time to introduce the self-referencing relations. So we said that employees represents different types of people, including managers or direct reports. That means that an employee needs to have a manager field, which is a type of employee, right? It's self-referencing. It's going to have this manager is going to have the same exact fields as the employee itself, right? They'll have their own contact info. They might have their own tasks. They'll have their own ID and their own name. Now, if a employee is a manager, they might also have direct reports, right? So, and that can go both ways. You could have a manager and you can also have direct reports. So, in a hierarchy in a typical company, you'd have something like that. So how do we do this? We're gonna do many to one here, right? Because typically you would only have one manager, right? So many employees map to typically one manager, and at least in most companies, you're not gonna have more than one manager. So this makes sense to be a many to one relationship. So we're gonna do, again, same thing. You provide type, and then we specify. So if you think about it, what does a manager have? It's got direct reports, which is why we added it down there. We're also going to add here on delete set null. Again, similarly, if imagine you're in a company, right, and your manager decides to leave for another company, we want to make sure that when that manager's record gets deleted, it doesn't just delete the rest of their direct reports record. So you don't want cascade in here. We just want to set null, because likely in the future, right, you're probably going to get a new manager for that set of reports, direct reports. All right, and then what do we do for direct reports? You're probably seeing where this is going, right? Which we're going to have one to many on this side. And why is that? Because any given manager has one to many direct reports. And again, what does this map to in our entity is the manager. All right, and I know we're kind of doing a lot of setup here, but we're also going to I'm going to show you how to insert data with these relationships, as well as how to query them. But for right now, it's much easier to begin with the end in mind, right? You start with your data model, and then you kind of fully implement it, and then you can do your queries and stuff. So back in our requirements, we did the self-referencing managers and direct reports, and then we're gonna do on delete set the manager to null. Now, the last thing we need to accomplish here is a many-to-many relationship with a meetings table. So again, we're going to create a meeting.entity.ts. And just to save you some time, because you've already seen what I'm going to type here, right? I just made a new entity class called meeting. It's got its ID. It's got the Zoom URL as a column, right? Meetings usually, that's a virtual meeting maybe. And then the thing that's probably new at this moment is we've got a many-to-many relationship with employees, so which we're going to call attendees. Now, again, similar thing. What does this map to on the employee entity? It's going to map to a meetings property, which is a list of meetings. Now, similarly, we're going to add a many-to-many here, and then we're going to add a join table. Let's make sure we got these imported. Now, to explain this join table a little bit, I pulled up the documentation, and you'll see that for the many-to-many docs, it says that join table is required for many-to-many relationships. You must put it on one of the owning side relation. And what this effectively will accomplish is our diagram here. Basically, when you do it that way, it's automatically going to create for you, TypeORM is automatically going to create for you the relationship table like this. Now, why did I put that join table on the employee side and not the meeting side? Well, I kind of think of it in a way that an employee can probably own a meeting, but it doesn't make as much sense to me to say that a meeting owns an employee. They do have this kind of intermediary table which represents the attendees, and you can configure that via join table here. If you look at join table, there's stuff that you can pass in here, like what is the name of that table that's going to be created. If you don't pass anything, TypeORM will kind of just automatically name it for you. Now, another question to ask is, what about the deleting behavior? Well, with many-to-many, it automatically kind of cascades by default, so you don't really have to configure it. So for example, obviously this table represents the relationship between the two. If an employee were to be deleted, it should automatically just remove their record in this table, right? There's not much more you have to do there. It does that automatically. And similarly, if a meeting got deleted, it's gonna delete all of those records that has that meeting ID. So it does that already for you automatically. We don't have to configure anything there. All right, so at this point, assuming I didn't make any mistakes, which we'll find out as we go through, but I'm pretty sure we have implemented everything that we need to represent this ER diagram. We did the many-to-many relationship with meetings, and we created a meeting table and the many-to-many relationship with employees. And then we said that this part is actually automatically handled for us, so we don't actually have to write any extra code. So there you have it. We got our schema. Now let's transition to how do we insert data into our database, knowing that we've got foreign key constraints, right, on some of these. How do you create new records for each of these tables, as well as the relationships between them? How do you do that in TypeORM? So that's what we're going to cover right now. So if you watched my previous TypeORM video, you probably know what we need to add here, right, which is a TypeORM module for a feature, which basically provides a list of the entities that we want to be able to access within our service. So let me just make sure that these are all imported, right? So we're getting all of our entities. We're gonna add it to TypeORM module for feature, and what that is going to enable us to do is within our services, we're going to be able to add injection here of our individual repositories, which allows us to query our individual tables. So the way you do that is usually within the constructor here. There's a shorthand that you just do these inject repositories with the type, and then you just specify a name for that repository, and then it has this type, right? And I know I'm going kind of faster, but this is stuff that I did cover in my first TypeORM video. Again, ideally you watch that before this, because it gives you a lot of the fundamentals of how do you do this stuff in the Nest landscape. All right, so let's say that we wanted to perhaps create a function to seed our database. Now, obviously you would never do this in a real application, right? This is a tutorial, so I'm just trying to show you guys how to create records for each of these tables and how to relate them together. In a more realistic scenario, you'd probably seed your database using migrations, or maybe you'd actually call your API to add data. So just know that this is not representative of a typical application. But let's just get started here. Perhaps we want to create a new employee. We'll call him the CEO. And again, you might know from my previous video, is the way to do that is we do employee repo, which we have injected up here, .create, and then within this we can provide the fields that we want to give that record. So let's call this person Mr. CEO, right? And what is this exactly? This is kind of equivalent to doing CEO equals new employee, and then doing CEO.name equals Mr. CEO. So you can do it that way too, right? But that kind of gets ugly really fast with large entities. So it's better to just do it via create. It's much easier because our entity classes don't have a constructor, right? It doesn't have a way for us to provide it in, like this. So the create is very useful in this scenario, so we'll stick with that. Now, create doesn't actually save it in the database. I'm gonna make this async. To actually save it in the database, what do? We do await this .employee repo.save, and then we pass in that object. Now, once it does that save, that's when it kind of turns into an actual database record, which means at this point, the CEO now has an ID, right? It is now actually saved in the database. So you can do all sorts of stuff with that. So perhaps let's start with a we said that there is a one-to-one relationship between employees and contact info. So let's create a CEO contact info. So in this case, we'll use the contact info repo here, and we'll also do create. And we said that email is required. So we'll do, I'll just do email.email. Right, and at this point we don't have the relationship yet, right? And you know that we're probably gonna do a save as well here. Let me just type this out real quick, right? Which does the actual insert into our table. But how does it create the relationship between the two? Well, you've got two options. Since we already saved the CEO here and we said that we kind of have access to that ID, since our contact info also has this employee ID property, one way to assign that relationship is to do employee ID, and then we pass in our CEO that ID. So that's one way to do it, basically manually kind of relating via the ID columns. Now, what I would actually recommend you kind of start getting familiar with is another way to do this is by working with these objects directly. So if I do CEO contact info dot employee equals CEO, that will achieve and when you save that will achieve the same exact thing. It's automatically going to figure out that because we're saying this relation exists, a contact info has a relation employee, and we're saying that's going to be the CEO, it's automatically going to map that to have the correct employee ID on save. Right, and this is a pattern that you'll see throughout this video and in general, probably as when you're typically using the repository API with TypeORM. Right, so at this point we've got a new CEO. He has a contact info, and we've made the relationship between that contact info and the CEO. Let's go ahead and create another employee. So let's create a new employee as the next person in the chain, maybe the manager. We'll give that, let's make that me basically, and we can also assign the manager of the manager to be the CEO, right? They report to somebody. The only one that doesn't really have a manager is the guy at the very top, right? And you'll notice I just added manager down here instead of outside like this. You can do it either way really, but I'm kind of just showing you the different options. Right, so I'll show you guys when you run this. I'll show you what it looks like in a database in a second here, but let's just create a bunch of things to kind of show you how to do a lot of this stuff. So we also said that an employee can have one-to-many tasks. So let's start creating a couple of tasks to assign to this manager, aka me. So again, you're probably seeing the repository API pattern by now, right? You do a create. So here's task 1. I hire people, and then you can insert that in the database directly. We can do save task 1, and then similarly we're adding a second task, which just maybe I need to make a presentation to the CEO. We'll add that and also save it, insert it to the database. Now notice in this case we haven't saved the manager yet, right? So the manager is not yet in the database at this point. That's because I want to create a couple more things in here. So we're effectively going to assign these tasks to the manager. And how do you do that? Doing this kind of notation, right? So we have the manager object. You can just via the property of the relation, you can just assign him like that, right? So at this point, if I were to save the manager right now, what's going to happen is it's going to insert that new manager record, and then it's going to update these two tasks to have the employee ID of the manager, right? What's another example of this? We said that we have a many-to-many relationship with a meeting. So let's create a new meeting. Now, perhaps the meeting originally only has one person in it, which is the CEO. So we can do meeting1.attendees, and it's just the CEO. Right, and at this point, if I wanted to, I could just save the meeting directly, and what that's going to do is it's going to create a new record in our employees meeting table, which is going to have the CEO's ID and the meeting's ID to kind of say that the CEO is an attendee of this meeting. Now, what happens if we want our manager to also join that meeting and it's already been created previously, right? Well, because we have this bi-directional relationship between meeting and employee that we created, you can also do meeting that manager that meetings equals meeting one, and by the time you save the manager, it's also going to create that relationship for you. All right, so hopefully that makes sense. Let's try to kind of summarize what we created here, right? We made our employee one, which is the CEO. We made and we gave them contact info, and then we created our employee two, which is the manager, and we gave the manager 2 tasks, and we created 1 meeting, which started out with just having the CEO, but eventually the manager also joined it, right? So we're gonna run all of this code, and we're gonna see what our database looks like from here. So the way I'm gonna run this is, since we already have this basic app controller, which has access to that app service, what I'm gonna do is I'm just gonna add the call to seed here. Again, this is not representative of an actual application, but this is just an easy way for me to demo this stuff. So I'm going to call seed, and then we'll just print out seed complete, so that by the time it returns, we know that our logic already ran. So I think at this point we're ready to run our seeding logic here. There is one typo that I noticed I had, which is in our config here. The path should not have src here, because the way that our code is set up, it's not going to have that src folder in the dist. So just watch out for that if you're following along. All right, so from here we should be able to now run our application via npm run start dev. Right, so our application run, and I should be able to trigger this. I should be able to trigger our seeding code by going to localhost 3000, right, which is just our basic route. And once it completes, it's going to tell us seed complete. Now let's go ahead and verify that happened. Notice that I'm using dbeaver here as our way to look at our database, which is just this file that got created on the desktop. So I'm going to create a new connection in here, SQLite, and I'm just going to select DB in the desktop, right? And just a reminder, that's coming from this config right here, which just says save it in the folder outside of this project, which is just our desktop in this case. So I'm going to select DB here, hit open, and hit finish. If we take a look at tables, we'll see the tables that we talked about. Real quick, you can also do view tables and ER diagram, and you should get to the same exact ER diagram that we started with, that we had in the beginning of this recording. But let's take a look at the data that got saved, and we'll also compare that side by side with the code that we wrote. So we said the first thing, we created an employee, which is the CEO, and also eventually we made a manager down the code. So if I were to query the employee table, you'll see Mr. CEO with ID 1 and the manager, me, with ID 2, and it has manager ID as 1. So just at that, you know that there was a relationship created when we did the manager CEO on line 34 here. That's what it kind of automatically mapped it to have manager ID 1, which is the CEO's ID. All right, let's also take a look at contact info. So you'll notice that we have a single record in here with the email and employee ID as 1, right? So again, that maps back to our CEO, who has an ID of 1. What else, right? We created 2 tasks and assigned them to our manager. So if I were to query tasks, there's 2 things in here that has employee ID of 2. And then finally, our meeting, right? There should be a single meeting created, which is just at meeting.com. And then we can see who the attendees are by looking at the relationship table here, which you'll see there's a record which represents the CEO attending that meeting, which we have in the code on the right here on line 45. And then there's also a record here which represents the manager joining the meeting as well as an attendee from what we did here in line 48. Right, so to summarize, right, I hope you kind of get the point of you can do relations by saving and creating individual things, and then basically just assigning them as if they were regular objects like that. And then when you hit save on those, it's gonna make them real, right? It's gonna auto assign the necessary IDs that it needs to assign wherever. All right, so hopefully that gives you a pretty good overview of how to insert and kind of make the relationships between those inserts. Let's go ahead and start talking about, all right, now that we have these related items, how do we go about querying things together, right? Perhaps I want to be able to query a manager with their direct reports, right? How do we do that? So in our app service, let's go ahead and create let's make this get employee by ID, which takes an employee ID. And remember from my previous video, we said that you can do a select all using find, right? This will do select all from the employee table. And you can also do find one and pass an ID there to get a very specific person. Now, how do you get the related things with this query? Well, what are the relations that the query has, or what are the relations that the employee has? So if we take a look at our employee entity, pretty much any of these things that are many-to-one, one-to-many, one-to-one, any of these relations are things that we can include. So for example, we can add a relations array here, and we can just add in here all the things that we want to pull in. So for example, I want to get the manager, direct reports, what tasks do they have, contact info, and finally what meetings are they in, right? And these are strings that represent these relations, right? Meetings. So the name you provide here is the name that you need to provide as a string to that relations array. So that's saying that you wanna kind of behind the scenes, you want TypeORM to do all the joining and whatever to pull these in. So let's take a look at what this looks like if we were to update our controller to now instead return this.appService.getEmployeeById, and we'll just pass in a 1 here. Remember that our CEO, our very first employee, has an ID of 1, so that's who we expect to get back when we run this. So again, I'm gonna run the application npm run start dev, and once that's up, let's go back to our localhost 3000, hit refresh here, and we get back the information of our CEO, right? So on its own, if we didn't have that relations array, it should just return us the ID and the name, but because we added that relations, it pulls in the manager, which is now in this case, it pulls in the direct reports, the tasks, the contact info, and the meetings, right? And just to kind of prove this is working, let's switch to the manager's record. So I'm going to give it an ID of 2. That's their ID in the database. If I hit refresh here, you'll see now it's the manager. We can see who their manager is. And then we didn't assign any direct reports yet, so this is empty. But we did assign them tasks, and they also belong to that same meeting with the CEO. Now that's one way to do it, which is the find API, right? That's not necessarily your only option. So if you know TypeORM well enough, you know that you can also create custom queries using the query builder. So an alternative way to do this, and usually when you have more complex queries, you'd use the query builder. So you might do something like this, .employee repo, .create query builder, and we pass in an alias here, we'll just call this employee. And then the way you pull in relations is by actually just doing joins, right? So maybe if you're more familiar with SQL, this should just make sense to you. So you should be able to do a join and select, where we use that alias, and we want to pull in again the relation, and we'll provide an alias for that as well. So this is going to pull in the employee's direct reports, and we'll also add in our meetings and tasks just as an example, right? And then you'll notice that there is an alias for each one of these, so it's still kind of represented by some kind of string, and that's useful in scenarios where perhaps you want to add, a where clause, right? Maybe you want to do where employee.id equals employee ID. Again, I'm kind of going through this quickly because hopefully you have some of the TypeORM fundamentals already. I'm just giving you the how to do it. So, and then don't forget to add get many here, or I'm sorry, this should be get one, right? And that should get us a similar result back in the browser. When I refresh, we get back that same object, except in this case we only pulled in direct reports, meetings, and tasks, right? So those are your two main ways to get related data into your query, which is if you're using the find methods, you use the relations, which is very convenient, by the way. But for more complex queries where you might have more additions like group by, where clauses, order by, stuff like that, where you really need to utilize those aliases, you'll probably want to use the create query builder. And specifically, if you really know the SQL well, you'd probably be able to map the SQL to the JavaScript API much easier than this find abstraction. So that's up to you. All right, so pretty simple, right? And now just to kind of prove that our on delete constraints are working properly, let's go ahead and do let's add a delete employee method, which again takes a number as an ID, and we'll just do return this dot employee repo dot delete, and we pass in that ID. All right, so let's go ahead and trigger our CEO to be deleted. I'm going to change this back to 1, and I'm going to change this to delete employee, and then we'll take a look at what happens after that deletion. So I'm gonna refresh here to trigger our delete. You can ignore that response from now. So back in the database, if I query employee, now it's just the manager, CEO is there, right? But we set that manager's manager ID to null because that employee left or got whatever, and contact info should be empty now because we deleted the CEO, and that automatically cascaded the deletion to the contact info. And in the relationship table here for the many-to-many with meetings, effectively our attendees list, we now have just the one record because again the CEO got removed. So automatically we said that TypeORM is going to handle that for us, and it did, right? And then one last thing, let's make sure it's also working for the tasks. We said that tasks should stay there if they get deleted. So in our code, let's delete our last employee, which has an ID of 2. And let me refresh this browser again to trigger that. Now back again, the beaver employee is not now empty. And what I expect to see in the tasks table is that the tasks are still there, but the employee ID is null. And again, just a reminder, why is that? Well, when we go back to our task entity, right, we said that on delete, referencing this employee, we should set the IDs to null. All right, so that I think that just about covers the fundamentals that you need to know in terms of how do you create relations, how do you represent the schema for that, how do you do inserts and actually relate the table, the records via the saving and stuff like this. How do you query it, and how do you kind of make sure deletes are doing things correctly? We talked about all of that. Now there are some other things that you want to take a look at. For example, you might have noticed that we individually have to save everything here, right? Each entity we have to manually save. There is a way to prevent that or improve upon that, which is via cascades. If you want to look into it, yeah, there's this property that you can assign cascade true, and it's going to allow you to only have basically one save. Like in this example that they have in the docs here, instead of them having to manually save each category, right, you can kind of just assign it, and it's going to cascade that saving across those categories. If you kind of compare that with our code, notice that in our task 1 and our task 2, we're manually saving each one of those right before we can do this thing. If we were to have cascade true, you can remove this, and by the time that you save the manager, it's automatically going to save those two tasks, or in this case, when we say save, it's going to insert in the database. Now, I didn't explicitly try to go over that too much because in my opinion, it might make it confusing because to me it adds a little bit of magic. You don't know when things are actually being saved or not. So for me, I personally prefer the more explicit way of calling save on each thing. That's fine with me, even if it adds a little bit of code personally, but you should know that you have a way out of that if you don't like it, right? And Cascade also has some stuff about, maybe you want to only do that in terms of like inserting, updating, deleting, or everything. There's a little bit of configurability there that I recommend you check out if you're interested in that. One last thing I want to mention is that you can also do eager and lazy relations. So for example, if we go back to our code, so as an example, back in our code, again, remember that we're kind of explicitly saying what do we want to be included with the employee data when we find them. For example, it includes this thing. Now the eager, what this allows you to do is says, what if you want to always include tasks, for example, regardless of whether or not you include it in the relations list, you can do eager true here, and it's always going to pull in the tasks every time you query the employee. So you have the option to do that. There's also the option of doing lazy relations, which I'm going to be honest, I haven't had a good use case for in my own work. So, just know that it exists. It's there. It basically allows you to lazily pull in the relation later via async and await like this, like with promises. I don't know. I personally have not had to use that. Plus, it makes the type be a promise like this. So I don't know if that's a good thing or a bad thing for you. In my opinion, it makes it a little bit more confusing to work with. But I'm sure some people will probably have a specific use case for that. With that said, guys, hopefully that was a useful tutorial for you. Make sure to let me know in the comments if you have any good or bad feedback. I'd love to hear it. If you've made it this far in the video, perhaps you like the content, maybe it's providing value to you, make sure you subscribe, hit the like button. With that said, I'll catch you on the next video. Thanks for watching.